I've quite a lot of content to get through, so I'm going to get started while folks are filling in. Let me reset that, and let's get the show on the road. Hello, I'm Christiaan. I work for Google, and even the animation worked. I wear 3 hats. I'm the co-chair of the FIDO2 Technical Working Group, the FIDO Alliance. I also do work on our platform implementations for Passkeys. So when you have the standards, we then have to put them into practice. So we implement the Passkey or FIDO standards in our platforms, such as inside of Android, inside of Chrome. So any developers, like anyone here in the audience, can start to make use of these standards and the implementation thereof. And then lastly, what I've been spending most of my time on for the last year is then taking the implementation that we now have in our platforms together with the implementations we have in other platforms, like the implementations in Edge that we saw this morning, the implementations in Apple platforms, so Mac OS, iOS, iPadOS, and taking those and implementing them for the use of Google account security. And I'll talk a little bit about that towards the end of my presentation here today. So on the 4th of May, Google launched passkey support for any Google account. I'll step through the experience in a little bit. I'm hoping that by the end of this session, I've convinced everyone here that has not done this yet. If you have a Google account, that you will go and set up passkeys, and you can do it right here. That's the one reason to be on your phone while I'm speaking, is like set up passkeys on your Google account. And then hopefully by the end of the presentation, there will be 5 minutes for Q&A, and then you can come tell me how well that went. So I think for the first time, we're super excited that we're able to, this is the first presentation that I'm giving after we've done that passkey launch. So for the first time, we can actually talk about the issues we've hit and the experience and the UX research and everything that went into making that launch possible. And one of the key reasons for doing that launch really is to show folks here. It's not so much to get passkeys out to our users yet. That we want to do. But the first kind of like step here was in order to show to the rest of industry that number one, passkeys are here, passkeys are ready, and to give developers a hopefully good reference implementation if they want to also go down the path of implementing passkeys on their own services. So with that, let me start with a very, very brief passkey overview. I'm pretty sure everyone here in the audience has some level of familiarity with passkeys and what they are. First off, passkeys, that's the passkey logo, or at least our version of the passkey logo. What are passkeys? Let's do a quick recap. Passkeys enable a user to sign into a site or some online service with a simple user gesture. It should be as simple as unlocking your device. That's like the high-level proposition. So if you unlock your iPhone by showing your face or touching your fingerprint, that is how you will be logging into sites and services on your iPhone going forward. No more do you have to type a password, and we'll get to the other point of that, and you also no longer have to do any other form of second step or multi-factor authentication. Passkeys are strong enough to essentially satisfy both the first and second factor requirements that users have. We'll get to that. So the whole position or the value proposition of a passkey is it solves 2 things. There's 2 factors. There is physical key possession, because remember, a passkey is nothing but a private key, and the private key is stored on your device. And then there is a public key that is kept by the service provider. And for a single user account, there can be multiple of these, which we'll see in the Google example here in a second. If I want to access my Google account, I might have a passkey on my iPhone. That might be a different passkey from the passkey that I have on my Windows laptop. That might be a different passkey from the one that I have on my Android phone. But all 3 of those passkeys allow access to the exact same Google account. That essentially means Google has to keep 3 public keys, and then there are 3 corresponding private keys on every device or every what we call sync fabric, which we'll talk about in a second, which allows access to that particular Google account or to that account. And then the key possession is one factor. So device possession or key possession is factor 1. And then the second factor is the user showing that they have ownership over that device by being able to unlock it at the point of sign-in. So that's the fingerprint, the face scan, typing in the PIN code or the pattern or the password to unlock the device. Those are all sufficient in order to prove that you own the device that you're on, and then secondly, the presence of the key is then what's being used, and a signature is generated based on that and sent to the server. This solves many different issues that we have with passwords today. Number one, password breaches. There's nothing to breach on the server side but a public key, right? If an attacker gets hold of the public key, they still can't sign you in because the private key is what's actually used in order to authenticate the user. The public key is just used as a check to check, yes, did the user have the right private key? So all these things go away. Phishing, number one issue that we struggle with, right? Password phishing. You can't be tricked into typing a passkey into the wrong site because there is nothing to type. And the system will ensure that a passkey will not be exercisable when you're on a phishing website or a site for which the passkey was not generated or not scoped for. That's all part of the protocol. It's part of the same protocol that makes physical security keys work. That's why we were so excited 10 years ago when physical security keys started popping up. We've been using them, for all our employees at Google because physical security keys have exactly these same properties. The problem was no one bought physical security keys. And we knew that. That was not like a big surprise. It's like enterprises bought them, some high-value targets and high-value users bought the security keys, but for the general user population out there, it's kind of like meh, right? I'm fine with my password. And we'll talk a little bit about that in the second year as well. We want to raise, I guess, like the waterline here for all users and essentially put a security key in everyone's pockets with a passkey. So let's talk a little bit about what changed from what we've been talking about for a number of years when we talked about WebAuthn and FIDO2 and FIDO credentials. What's different with passkeys? Well, three main things changed over the last, let's say, year, from FIDO2 credentials to where we are today with passkeys. Number one, a passkey is just a FIDO2 credential, right? It's a credential that lives on a particular device. It's a private public key keeper. Public key goes to the server. Private key stays on the device. But what's really cool about passkeys are they're FIDO2 credentials that can sync. Now, if you think about a password manager today, one of the benefits of a password manager is it'll store your passwords on your phone or on your desktop or laptop, but it'll also back it up. And it'll also synchronize it to other devices that you own, so when you need to sign in somewhere, the password is available. We need that same property for passkeys to be successful. It's not helpful if a passkey lives on my one phone and then I lose the phone or upgrade my device and suddenly I get to my new phone and there is no passkey available. So passkey synchronization is one thing, or FIDO2 credential synchronization is one thing that we have started allowing, but it's one thing that we've started to do as an industry in order to solve the problem of credential lifecycle, right? So I start off on one device. We know the user is going to change to another device or at some point use another device. We want their passkeys to be available wherever they are. So following almost the same rules as what password managers do, we follow those same rules in order to move passkeys or synchronize passkeys and keep them safe for the user and back them up in either their iCloud keychain or in their Google Password Manager or any other third-party passkey or password manager can do the same thing and provide the user their passkeys wherever they might be. The second thing that we started to allow is something called cross-device authentication, and this is kind of like where that weird QR code comes in. So imagine I am on a friend's device and I want to log in there to my Gmail account because I want to check my email. If I have a password stored in my password manager, I'll open my phone, I'll view my password in my password manager, and I'll retype it on the keyboard of my friend's device, and that's how I can temporarily sign in on a device that I don't own. When I'm done on that friend's device, I can sign out again, and all's well. With passkeys, because there's nothing to type, how would that even work? And of course, that is also, that action of retyping a password and not having it autofilled, that's kind of the riskiest action or the riskiest thing you can do, because if you type that password into the wrong website, a website that pretends to be Google, that's exactly where you get phished. So with passkeys, we wanted to allow that mechanism of signing in temporarily somewhere else where you don't have your passkey yet, but we allow that with a safe protocol called Hybrid. It's the cross-device authentication flow. So essentially how that works is I try to log in on device, laptop here, friend's device. I have my passkey on my phone. all I have to do is bring my phone close enough to my friend's laptop. I have to scan a QR code. There's some Bluetooth connectivity that happens to make sure I'm not being tricked or duped into allowing an attacker in a different country or different room to log in. We make sure that there's proximity between all these devices, and then the user is allowed to get signed in. Your passkey is not transferred to your friend's device. Mere presence or the acknowledgement that you have the passkey on your phone is what's being transferred. So it's a digital signature, essentially, that goes via your friend's machine to the server, and then you can have temporary access on that particular device. And again, you'll see most of this stuff in action with Google's implementation here in a second. And then the last thing that's really cool about passkeys is, passkeys are what we call discoverable. Today, passwords aren't the only gripe. Usernames are kind of just as bad. You need to remember them. Mostly they're email addresses nowadays, but there's still lots of services that, for some reason, kind of force you into creating usernames that, is almost like a password. They kind of make no sense. They can't contain an @ so you can't make it your email address. If you ever change your email address, like what happens to the username, there's always a whole, messy angle there. So if you have a passkey, these passkeys can be surfaced to the user at the point of login. So at the point when you want to log into a website, if you click into the username field, if you happen to have a passkey available for that website, the system will automatically pick up on that and show you a list of your available passkeys, so you can simply click on the one you want to use, touch your fingerprint on the sensor, or show your face, or whatever you do, and immediately you're signed in. So very similar to the autofill experience that we're all used to, right? Browsers started doing that in a helpful manner, number of years ago, where if you have a username that you type often, we'll start to remember it. The next time you come back, we'll kind of like show you the username again, but it's all based on heuristics, right? Or mostly. With passkeys, it's explicit. If you make a passkey on a specific device, a website later on can tell the browser, just show the user all the passkeys available and make it easy for them to sign in. And that's what you're seeing there. I'm clicking into the account name field, and all the available passkeys are enumerated, and I can just click on the one I want to use in a fairly straightforward manner. So these are the 3 additional, call it value adds, on top of where we were with FIDO2 credentials maybe about a year and a half ago, that really makes FIDO2 into a passkey. So passkeys are available almost everywhere. They're available across Apple, Google, and Microsoft platforms. There are some other platforms that we are, busy engaging with and working on. But this essentially means that, where your users mostly are, passkeys are fully available, and you can actually deploy them today at scale. Like I said, there are edge cases, like if you have users signing in on some, television somewhere in a hotel, yeah, maybe there is no passkey support there yet, so you'll need to do something else. But for mainstream logins, across Apple, Google, and Microsoft platforms, users should be able to use their passkeys there in a pretty consistent manner. As I said earlier, passkeys don't only replace passwords, which is really cool. If you happen to have a site that you sign in with using both a password and some form of MFA, multi-factor authentication, whether that is via SMS, like an OTP code, or maybe a Google Authenticator, or maybe some push-based authentication, passkeys can replace both of those steps, right? So if you sign in with a passkey to a website, you just do one gesture. You just touch your fingerprint on the sensor, or type your PIN, or whatever, and that proves that you have access to the key material and that you own the device that the passkey is on, and that should allow the user then to be logged in. So it's an easier user experience than what users would have today, while raising the security bar significantly over what we've got today because of the remote data breach issues that goes away, and also the phishability issues. And phishing is likely probably the #1 threat here, because multi-factor authentication in most cases are there to try and guard against, server-side data breaches, because it's a dynamic credential that if someone breaches something, it's okay, they have your password, but they don't have the other part of the multi-factor authentication. Phishing, unfortunately, works even on MFA-enabled accounts today, as we know, and we're seeing more and more breaches happen as a result of multi-factor authentication being defeated in real time. So passkeys solve that problem while giving users an easier user experience. So now I want to talk a little bit about communicating the value proposition to our users, because that was challenging. We have all this technology, and we wanted to bring this to our user base. And like I said, we launched on the 4th of May, and we've done a lot of work to figure out how exactly to talk to our users about passkeys and what benefits it brings. So if we look at that triangle there of security needs, right, we kind of like think about it as like having these 3 points, three things that a user needs, right? Confidentiality or security, privacy you can call it, there is integrity of data, and then there's availability or how easy it is to access stuff. Turns out that users over-index on availability. They would much rather have technology that is less secure in nature, but, with less of a chance of lockout than over-indexing on something like, security or on the integrity side. So if you overemphasize, like for example, security keys is a good example of this. Now, security keys also cost money, but even in cases where we went to events and we gave out 20,000 physical security keys, users would be worried about losing the key and, losing access to their Google account. So there was this nature, not even just on the financial side of things, but I didn't want to lose access to my Google account. So it was very, very important for us with Passkeys to strike the right balance and have the right user narrative and index on how easy this is and how easy it is to retain access to your Google account. So, taking that and then translating that into some actual UXR that we've done or user experience research, what worked for us, we tested all these various phrasings or positionings when we talk to users about passkeys. I'm interested in using passwordless based on what statement? Because they're faster and safer, because they work across all OSs, because they're protected even if I lose my phone, right? I'm not going to go through all of these. But it turns out that the one that won essentially is because the speed, simplicity, and efficiency of passkeys is what persuades me to use them. And that basically meant that when we started designing our UI, which again, you can see when you enroll into Passkeys, which I'll talk about later, we've tested various types of messaging to users in real time after we've done our qualitative studies. And the ones here, again, that one just showed us, kind of like as a double study here, that the ones that got the best opt-in success rates were the ones that emphasized simplification of sign-in experience, and then there is some iconography that kind of like came with that users also, more colorful and, having a more cohesive experience. But I think more for me on the writing side, right, talking about simplification rather than security is the number one thing that stood out. And I think Passkeys I saw there is another talk this afternoon about, FIDO2 and silver bullets. I think Passkeys are to a certain extent that silver bullet where we're able to make account access easier, we're able to simplify while at the same time raising the security bar. And that's not something that happens that often. So essentially, again, just to recap, we want users to remember we're here to simplify their authentication experience. Yes, it also improves security, but the number one thing we want them to anchor on is simplification. So now, let's in the last couple of minutes look at some user journeys of our deployment. So let's look at the stuff in the wild. So how does it, look to create a passkey on a Google account with all of that we've just done and kept in mind? So the way that it works for Google accounts is once you have told us that you want the passkey experience, and I'll tell you a little bit later on how to do that, when you sign in on a new device and you type your username and you type your password, we're going to tell you, you have the ability to upgrade your login to a passkey-enabled experience. We only do that if we detect that the device you're on fully support the passkey experience. And there are some APIs for doing that. So if that happens, we're going to prompt you. Hopefully the user will say continue. And again, you'll see that we talk a little bit about simplification there as we discussed earlier. So there's going to be some browser-based UI or some system-based UI, and again, that's a point of friction today for some users because we have to hand off to the platform. Like we saw in the demo earlier this morning on the keynote stage, there is a process where a user interacts with Google in the browser, and then suddenly Windows Hello comes in, and that's because the user is on a Windows platform, and the user has to interact there. So for us, it's important to make that handoff process as seamless as possible, which is why it's important to be consistent in our use of phrasing and terminology, which is another reason why we think Passkeys is a good word for users to start to understand what the experience is that they're going to get because of this handoff, right? The user starts on the web, they might see Windows Hello UI, or they might see UI in iOS or Apple UI. So it's kind of important for us to be consistent there, so users don't get totally confused about why they're seeing different parts of the system interact with them in inconsistent ways. So here is browser-based UI that says you can create a credential. Then a Chrome pop-up comes in that says you can touch your fingerprint. That's how you create the credential. And now the user is fully signed into Gmail. Great. Now you have a passkey. How does it look like to sign in now that you have one? So if you go and you try to sign into Google, this is a mobile UI. User types their username. No password, no second factor. You get your screen that says, hey, we're going to prompt you for a passkey, and then you're going to touch your fingerprint on your Android phone, and immediately you'll be signed in. If you have passkeys, we need to give you a way to manage them, because you can have a passkey on your Windows machine. You can have a passkey on Android. You can have passkeys in the iCloud keychain. If you have a passkey in iCloud on your iPhone, that same passkey is available on your MacBook, and it's available on your iPad because, passkeys sync, as we said earlier. It's available in your iCloud account. So this is our management interface. And again, g.co/passkeys. That's what I would recommend everyone here goes to on their phone or on their laptop. That's where you get started with passkeys. That's where you show us intent that you want to get started. And that's also the management surface where you can see which passkeys you have. You can remove passkeys. You can add passkeys. The screen kind of looks fairly simple, but it can also get totally out of control, right? That's my account, right? I have many, many, many different passkeys across many different surfaces. Some lives on physical security keys. Some lives on Android phones. Some lives on old U2F keys. All of this kind of gets consolidated in this experience here. So yes, the experience can get a little bit too much, but for most users, they'll see a very simplified experience like the one over here. Does this work? Yeah, we published a blog post. There's the link down at the bottom. We have some data over the last 2.5 years where in certain surfaces we have been running experiments based on FIDO2. We think that passkeys are not only much more efficient in terms of getting users signed into their account, but it also takes them less time to interact with us and ultimately get signed in. And the link is down there at the bottom if you want to take a look at the source for this data. You might say, I'm convinced. This all sounds great. How do I get started? This presentation is not supposed to be like a code lab, but I did want to just show a couple of lines there. On the client side, to make passkeys and sign in with passkeys, fairly straightforward. It's a couple of lines of code. I don't know how many, 15 lines of code to do most of this stuff. Unfortunately, though, most of the heavy lifting happens on the server side, right? You need to store credentials. You need to validate signatures. Luckily, there are many open source implementations available. There are, vendors at this event that have servers commercially available. So I would recommend you look into those. But on the client side, at least, pretty straightforward to use and sign in with a passkey, right? How to bring these things up, how to detect whether or not the technology is available. It's all there in the specification. So again, I'll put my CTA up here. Please visit g.co/passkey or passkeys, doesn't matter, both work, to give this a shot. If you have a Google account, highly recommend you do that. There is no downside. Your password doesn't go anywhere. It's still there. It's still available. This just becomes an alternative option, and you can use this, as I mentioned, whether you're a 1SV account or a 2SV account, doesn't matter. It'll work for both. If you are 2SV, you get more benefits because your passkey will replace both of your factors here at the same time. With that, thank you. We have 1 minute, so in case there's any burning questions, happy to try and take one or so from the audience. Yeah, sure.
So, you described the main benefit for this, what I understood is the porting of my credentials to the entire cloud, so all my devices can read from that.
Right.
It works well for something like Apple or Android ecosystem, but you also demonstrated about Microsoft Windows scenario. But that Windows scenario, my credentials just exist locally on that machine.
Right. Yes. Yes. That is correct. So there's two answers to that. The one is, friend, you're in the front row from 1Password. If you use a third-party password manager, that's one way to get credentials across different systems. However, the other option is most users don't only have a desktop. There are some users who only has a phone, but not a lot of users who only have a desktop or a laptop computer. So the user who has a credential only on their Windows machine, they most likely also have an Android or an iOS device which also has a credential, which means if they come to another device, yes, the Windows credential is essentially landlocked. It's not going anywhere, but you can always use your phone with that QR code-based flow to bootstrap yet another device, which will then create you another passkey on that particular device. So it's not completely, I guess, like nonsensical to have these essentially landlocked credentials, but over time, we are hoping that the synchronization story will become more robust. I think we're completely out of time at this point. Thank you so much.